All right, or 6 of us, good. Well, we're going to go over tonight ping exercise and tracer. And first we'll go over some discussion notes on it, and then we'll go right into the lab. Next week is a Cat 5 lab, and I just put in here a couple notes. Get a good night's sleep, and we will stay the entire time until everyone's finished, as far as your row anyway. I think I already mentioned that. You'll be creating in the lab next week a straight and crossover cable. If you look at the back of the room, the white cables are straight cables, the red cables are crossover. And crossover allows you to connect two computers together without the intermediary device of a hub or switch. And so you'll learn how to do that, because in networking a lot of times you'll need those skills on the fly to build a straight cable, crossover cable. And so we'll be doing that. So I've already got the notes up here. I want to go ahead and get right into the tracer lab, or the ping and tracer demonstration. First of all, skills, what they're for, tracer and pinging both, is basically a skill set needed for IT whenever you work in any department in IT. And basically the concepts that they cover is like router hops, IP, network transit, IP registration database, the internet as a network of networks, backbone of a network. So in order to determine the health of your network, both locally on your PC and via internally on your business network and externally to other websites that we're going to do tonight, the ping and tracer help you determine that, okay? A lot of things factor in pinging and tracer. One of the things that we'll look at in a document in just a second that's in the lab folder is the history of ping. It actually began in the Navy with sonar, and sonar, if you don't know already, whenever it casts its beam out, its sound waves out, that it hits something and comes back, and that determines how far away the floor of the ocean is, how far away another object is. The same concept in networking. When you ping another server or another website, you're seeing how long it takes from you to that person, to that device and back to get there. And not really distance in networking as it is in sonar with ships and objects. It's more of congestion can cause issues on the travel, but whether it be slower or faster, failed switches, bad switches, things of that nature. And so technology has come a long ways, but this is still heavily used in networking, pinging and tracer. And we're going to go over both of them tonight. So let's go to the first definition of ping, which is basically the measure of time for a packet to travel to a remote host and back. The server sends back an acknowledgement when the packet arrives and says, okay, I've received you, now I'm sending you back. It's kind of like if I threw you a tennis ball and you threw it back to me, same concept. However long it takes you to bring it back, maybe your arm's not so good, or maybe you're not feeling well, or you drop the ball, whatever. A lot of factors could go into play on how fast you give it back to me. So it's the whole concept of pinging is that. If you any online gamers in here ever played an online game before? Okay, pinging is essential. Having a low ping, low latency rate. It's probably what I think gaming platforms use. They used to anyway when I used to play. I used to teach high school, and so the kids used to talk me into hosting LAN parties on Saturdays every once in a while. Anybody remember those LAN parties? You bring your own computers and your switches, and they play. I think back then it was Counter-Strike was the big one, and in fact I know it was Counter-Strike because I taught a C++ class, and one of the things they talked me into letting them do too was developing maps for their Counter-Strike menus. They had different maps that they could build using C++, and so, but anyway, back then, even then, we set up our own internal LAN. I would bring a switch, one of the students would bring their own switches, and they set up their use the lab computers, or they bring in their laptops or whatever. And there was a host that would set up a host server for Counter-Strike locally, and it was a separate application, a separate program that had to run. And then once that host was set up, then the clients could connect to that host. And again, it was internally, no internet at that time that we used, it was all internal. But say a switch was bad, or one of the ports on the switch was bad, or maybe one of the laptops or desktops NIC card was kind of going, it would affect the latency of data getting to and from that device. And latency in first-person shooters is death. And so, yeah. And so it's used a lot in gaming still, but it's also used a lot in general health of a network. There are utilities that do pinging for you as a network admin to determine the health of a server. And if it gets below such and such a ping, or say it gets too high, let's say it takes, I'll just throw an example out, instead of taking 2 milliseconds to return, it starts taking 10 milliseconds to return. And you might have a threshold that says, okay, if it gets to 8 milliseconds to return, I want to be paged. And we have software that can do that and page the admin saying, hey, something's going wrong with the server. The pinging's taking 8 seconds or more, red flag. And generally 9 times out of 10, if the admin's not on site and they're at home and they have a tech working like here in the evening, they just have them restart the server. And everything's back to normal. Windows servers it's very prone for that to happen in Windows servers. And it could be a process that's running that just keeps running and running and running, slowing that server down. No telling what it is. But instead of trying to figure it out, the easiest way that most network admins, and including myself, have done is just restart the server. Now, if it's something that happens all the time over and over, definitely you have to figure out what's going on. But normally it's sporadic. And so pinging helps you determine that. Yeah.
Which level of the OSI model would that fall under?
Which level? That would fall on the hardware level, going to your NIC card, and so there'd be a network level and your network interface level going into the NIC card. So you got your application layer, your session layer, and then going into the actual hardware layer of your OSI model. And so that would be between that area.
So when you're having a constant problem, like you were saying, with something like that, that's when you would start thinking about the OSI level or the...
Well, in that case, it's normally it's going to be a couple things. If it's a ping issue, it could be that, again, the processing power is down low, really low, and so it's just taking forever to respond. It's sluggish. That's normally the case on ping. Has nothing to do really with the NIC card or the Cat5 cable or whatever's connected to it. So more than likely it's going to be like on the application layer, the session layer, because it has to do with the processing power of that machine. So more than likely it'll be on like the app. Some session is locking it up and slowing it down. Yeah.
Could it be possibly a bad IP address to it and it's trying to hit something? Could be a routing system of it where it's
it could be. It could be, but more than likely it's just the congestion, or it could be congestion on the network itself as a whole, or the most time I've seen it is the server itself is reaching the end of its memory cycle, and it's, for lack of better terms, it's very slow and sluggish and needs restarted. Yeah.
Wouldn't, if you get the wrong IP address, it would send a packet back? Right?
Yeah, it would fail. Yeah, it would fail. It would fail, and you'll see that tonight. But yeah, it would just fail on the packet ping. So the next one is tracer. This one is different than ping. What it does, ping is just one-to-one. I send something to a server, it comes back, and it tells me a couple things you'll find in a second. It tells me the round trip time, how long it took. It tells me TTL, time to live, how long that packet can live on my network. It tells me the IP address. If I type in a domain name like google.com, it also tells me the size of packet I sent that server, and they had to also send it back to me, and it's generally in a 32 or 64-bit increment, all the way up to 128-bit increment that it sends. So Tracer is different in that instead of one-to-one, me sending something coming back, Tracer lists a router hops between my client, the client that I'm on currently, or your client that you're on tonight in just a second, and the remote host. So how many switches, how many router hops technically does it take to get from me to google.com? And you have up to 30 hops that it can allow you to take, and you'll see an example of one tonight in our lab.
I forgot to tell you, I'm in the Cisco 1 class too.
Okay?
You can't pay from here?
We can. We're going to use an online ping.
Oh, okay.
Yep. In our lab, we're going to use an online ping service.
Okay,
We're not doing it internally.
We were pinging before.
Do I know?
We were pinging before and we couldn't get out because.
No, we're going to use an online website
Oh, okay.
that'll let us ping.
What they do in Cisco 1, they're pinging from computer, from PC to PC, router to PC.
Yeah, I know. Yeah. And they have it blocked in here, but we'll use an external site that'll let us ping.
Oh, okay.
Yep. Then ping clients. Windows has its own built-in ping client, so does Mac, so does Linux, and it has its own command line interface, not a graphical user one. It's run from DOS, and still works. So if you want to go ahead and start up this in your computer, click on the Start button on your Windows machine, go to the Run command, and type in CMD. Instead of COMMD, it's CMD. CMD, then just hit enter. As soon as you type in CMD, it will give you a black screen, a DOS screen, with your cursor blinking in it. The next thing I want you to do what now?
In the start menu, see if you got the command.
Yep. Yeah, well, some people don't know how to do this part, so I'd rather have you guys type it in. But yeah, you guys do have a shortcut to this as well on your desktop. Now, the command prompt that's on my screen, that was like Windows NT, Windows 98, beginning of Windows XP, though we started with CMD command. So if you're ever at an older computer and you can't use the CMD command, this command on the overhead will work. So what I want everybody to do now is we're going to do a simple ping. Type in the word ping, P-I-N-G, space, and then I want you to type in localhost, all one word. So ping space localhost, and it should kick back to you a local loopback IP address of 127.0.0.1. Okay? That determines localhost, all one word. That determines the health of your NIC card. If you were to get 3 back or 1 back and fail or 2 back and fail or whatever, if you didn't get 4, that determines or is a red flag that there's something wrong with your internal NIC card. So anytime you have a question on a computer that, hey, maybe the NIC card's going, you can do a ping localhost really quickly like we just did, and it'll determine if you get 4 replies back at 0.000 milliseconds return, you've got a healthy NIC card, and it's not that's causing the issue. Okay? So that's the first one, start run command. Then you just keep that screen in front of you. I've already went over this part here. You get the blinking cursor, you type in the ping command. Now, we're not going to do a website yet because we're going to use an external site in a lab, but if you were to use your ping client in front of you, you would type in something like this, ping space and then the website. And we'll actually use an external website to do this tonight that lets us do pinging and trace route and a whole bunch of other cool stuff. So the red arrow refers to the program ping. The green arrow refers to the actual remote host. And so here's an example of Pepperdine. If I was to type it in and get a reply back, notice it pings Pepperdine, and then right in brackets after that, it gives me an IP address of Pepperdine with 32 bytes of data, and it replies 4 times with those 32 bytes of data, meaning I send it 32 bytes, it brings back 32 bytes. Notice the timeline, the time area. It says time equals 37 ms, 38 ms, 36 ms, and 38 ms. That's 38 and 37 and 36 milliseconds. That's how long it took from the time I sent it until it came back, okay? And the next one is TTL. It's 114. That's 114 times iterations that this packet can live on a ping until it dies. 114 in this case. A lot of times you'll see 112, 110. It's built in to that NIC card, whatever that NIC card interface has. Could be up to 250 and 256 as well. The ping statistics it gives you at the end tells me I sent 4 packets, received 4 packets, 0 were lost. And notice it gives me a minimum, maximum, and average of round trip times. And no packets were lost. The average ping time was 37 seconds. And if you want to do this real quick, because we're going to be going there in a little bit, this website I have circling on the overhead with my mouse, you can go ahead and go to your internet browser. You can do a Firefox, or Firefox I'd recommend, or to do this. And go and just type in ping.eu, ping.eu, and I'll put it on mine as well. Do what now? ping.eu. It brings you to this page here. And just keep it on the page yet. We're going to come back to it when we do the lab, but I want to kind of keep it up there for you. And while we're at it, while we're on the internet real quick, let's go ahead and go to Eagle, because I want you to download a document, 2 documents actually, in week 4. If you go into week 4, there is a folder called week 4 lab. There's 2 documents I want you to download. There's a read document on number 1, and there's a do lab document on number 2. Okay, again, we're going into lessons, week 4 lab. And 2 documents, if you just click on the hyperlink in number 1, it'll ask you to open it. Go ahead and open it within Microsoft Word. And then you're going to do the same for the do lab. And we'll look at both of those documents in just a second. I'm going to come back to them in just a second. Okay, so let's look at some of the, while you're opening those up, this next slide talks about some of the prefixes that you might hear in technology and IT. Prefixes from deci to pico. Deci is 1/10, centa is a 100th, milli 1/1000th, micro 1/1,000,000th, nano 1/1000,000,000th, and pico 1/1,000,000,000th. Okay? After these prefixes, there's also a femto, an atto, a zepto, and a yocto, and each has 1,000 times smaller than the previous. Okay?
These are numbers?
These are prefixes for number types. These are prefix categories for number types. So you've heard of like decimal, right? Centimeter, millimeter. Okay, you probably heard of those. Micro, you probably heard of the micro term. Nano, you probably heard of, but ones folks haven't heard of probably is a femto, atto, zepto, and yocto categories for prefix. So ping utility, this is just an example of a Windows ping utility. We're going to be using an online one. The difference in this utility and the one built in is it's a GUI interface, the one that command prompt I had you guys go to, the start Windows command. Notice on this one, you can determine the packet length. You can also determine how many tries. Windows by default will give you 4 tries in a ping. Linux is unlimited tries, meaning it will keep going until you stop it. It's an infinite loop of pinging when you start it. The same with Macs, because built upon a Unix platform. You do a Command C in both platforms to stop the ping. But here in Windows, it's built in by default 4, and you can mimic it or stretch it in a command prompt and manipulate it, or you can use apps like this that will do it for you. Now, the other thing you'll notice on the right side is packets received, packets percent received, minimum time, maximum time, average time. These are actually coming in from the ping itself. It's filling that data in as they click on the ping button. The ones on the left, the packet length, number of tries, and delay, those are user input commands that can be used to manipulate the ping. The one on the right, though, cannot be manipulated. It's just a read-only text to show the results of that ping. So this is just one example of a Windows client. The next one we're going to talk about, before we get to the Word documents, is traceroute. It's pronounced traceroute or tracert. You might have heard it pronounced as that. Tracert or traceroute. You've got the program name in red and then the remote host in green. So you type in tracert space and then the name of the website, and then it'll bring up that tracer command. Now don't try it on these computers yet because it's not going to work because they're blocked. The next is the tracer results. If we look at the tracer results on this screen, you'll notice it's tracing yahoo.com, and it gives me up here an IP address, and it allows 30 hops to get to yahoo.com. But notice it only takes 10 hops to get there. This first hop is where you're at. This is your IP address where you're at presently. The second one, third one, and fourth one are in the order that they were actually hit to get to the final destination, which is the Yahoo web server. This 209.131.36158, which is the Yahoo website. You'll notice the first hop only took 4 seconds from your router to the next one, which was 39 seconds, then 35 seconds, so on and so forth. This one took 120 seconds, and then finally 49 seconds. Now, one of the things I wanted to mention on routers, notice, except for the local one here, most of these have actual names in the router titles. And the reason for that is so you can determine, a lot of these router titles will actually have in there, in a lot of cases, locations. Like it'll have city names in the router, like Chicago, Florida, AT&T Chicago, AT&T Florida, AT&T Ohio, AT&T Champaign Urbana, AT&T, so on and so forth. So you're actually being able to see from the name of the router, okay, about where it might be by just looking at the name, about where that router might be location-wise. Now this one doesn't make sense, but you'll see tonight as we play with some of these tracers in just a second, some of them actually do make sense with naming. But all this is doing is, again, you have 30 hops. This is you giving the tracer command to go to Yahoo. It goes from you to this one, 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 to finally the Yahoo server that you wanted to get to. So that's exactly what it took to get to yahoo.com. And so that's important because of congestion as well. You can determine from a tracer route congestion issues maybe locally, or congestion issues, say that you are the host for this site, yahoo.com, you're the owner, you're the company Yahoo. It's good to know your lag time on each one of these routers, because that could greatly determine whether or not people come back to your website or not, if it's taken forever for them to get there, okay? So you could have failed. Do I know?
Would that show the congestion?
It should be congestion. It could be congestion like on this 112.
Yeah.
That could be congestion. That could also be the servers going, the NIC cards are going, the router itself is going. So a number of different scenarios that could occur. If it's during the middle of the day, it could be congestion more than likely. And so there's a number of different factors. But let's look here at the hop explanation on this example.
Before you go, so
Yeah.
each hop there, that's the location on the router, or the router is giving that information?
Well, yep, and I'm getting ready to explain it in more detail for you. So number one hop, you'll notice, is my home LAN router. My home LAN router is number one hop. It actually says number one. There's only 10 hops in here. 2 through 7 is Verizon, my RSP router network. So you got, notice in the names, Verizon, 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 Verizon. This is Verizon. and this is Verizon as well. Doesn't have Verizon in it, but it's Verizon. Then 8 through 10 are the Yahoo LAN itself. It's getting into the Yahoo environment, okay? Notice Yahoo, Yahoo, and Yahoo is actually in the name of the router. So folks and companies that have routers, both ISPs and companies that host websites, purposely name the routers just like this. They name them with the names of the company, and these numbers, by the way, make sense to the company. They will tell them exactly location-wise where these items are located at. They have certain codes and frequencies that they put in there. The same with Verizon. These behind the Verizon.gni.net, this information here makes sense to the Verizon folks. They know exactly where that router is. So if there's issues with milliseconds getting too high, they can go exactly to that location, swap out the router, solve the problem. Okay? So the reason for trace certs is twofold. One is trace certs are normally used from folks, if your business hosts a website, okay, you're going to use this command a lot because you want to know outside of your place of business how long it takes for people to get to your website, and if it's taken a while, which one of these locations are stopping it from happening. Now, let me break it down even further. Say this is your business here, right? And you find out that this Verizon one is taking 200 milliseconds, and people are complaining because it's taking so long. You're not the one replacing that router, but you're contacting Verizon and saying, I'm the IT guy over here, I'm noticing on our trace cert, and you give them the name of the router, is taking 200 milliseconds for the last hour. Can you please find out what's going on? They'll create a ticket for it, figure it out. That's the job of trace cert. That's what it helps you find out.
I had an issue with my own website. Customers were coming to it,
Mm-hmm.
and they would get there and it would blank out. They would lose it, lose the website, or they would go to it and it would say page not found.
Mm-hmm.
So from my computer, the question be, could I did a tracer for myself to see what was going on?
Definitely. You can do a trace cert from any machine to that website, and it would tell you exactly the health of every hop that it hit. And the hops determine, here's how the hops are. Here's how the devices work. You got your devices locally. Now this guy, we only had one. We had one device locally on my LAN router, okay? These other ones are owned by Verizon, his ISP, okay? And then lastly is you're getting to the web server. Okay, so that's the only routers you're talking about. Your internal routers at your location, that could be the issue, or intermediate routers would be the ISP you're connected to, second issue. Third issue could be the actual website that it's hosted on, the routers on that location. Does that make sense? So only three areas of health issues: local, intermediate with ISP, and the actual web server host itself. Does that make sense? So this will help you determine that by doing a trace cert if you have a website for your business. Now, how do I know the IP address, this IP address, and this IP address belong to Verizon? You can query the WHOIS database for that IP address, and guess what? It gives you the information on that. And we're going to do that in just a second. You can query an IP address like, these two here did not have Verizon in the name. You just do a WHOIS to determine who that is, and guess what? Every ISP has to have a WHOIS in registry, so every website has to have a registry information. And notice when they do a WHOIS on this IP address, it's Verizon Internet Services. Okay? Now, what that means is any IP address that does not have Verizon in the name but is owned by Verizon, if you do a WHOIS, it's going to kick back Verizon. Does that make sense? So this is not talking about specifically that router per se. What it's talking about here is Verizon owns those IP addresses, and when you do a WHOIS, it will tell you in that WHOIS who owns that ISP, who owns that IP address. So if you do a who is on any IP address that you're questioning, whether coming into your websites or into your business or out of your business, you can do a who is on it on this tool here. We actually have one on the site you're going to go to, which will determine the owner of that site. Notice it gives you the org name, the ID, the address, and sometimes they'll even have phone numbers in there. Now here's a longer route. This would be Google Tracer. This one goes to 14 hops. Again, what is number one? Where is that at? Number one. Where is that located? Yeah, it's local, right? It's the local LAN environment. Then Verizon from 2, it looks like, all the way to 4. And then 5 to 6 is an alternate ISP backbone. And you figure that out by, you can do a DNS on it, who is. And then 7 through 11 is a level 3, a backbone again of the ISP. So these are all alternate Verizon ISP backbones all the way through 11. Then notice when you start to 12, 14, that's the actual Google LAN environment. All right? Each one of these are fairly normal. You notice here on this San Jose, which is in the level 3 backbone ISP, it's a little high, but it could also be a congestion during the time of day. A number of different things could contribute to it. Next, you have one that could be a requested timeout when you do a ping, whether locally on your local host like you guys did in just a little bit, like you did earlier today, or if you're doing a ping or a tracer. What this means is it indicates that the router security settings keep this router from revealing its identity, or the router and connection are very slow and they're dropping, 1 to 2. You can block folks from pinging a server. Web servers do it a lot. If that's not the case, you've got issues and it's dropping those requests with this type of line on your request command. So I want to go next to, you got those 2 documents I had you download. I want you to go to the first one, which looks like this, and I'll blow this one up a little bit. Okay, the first one, we're just going to go over some definition stuff real quick. It goes in a little bit more detail, but like history and stuff. So ping and tracer, we talked a little bit about it. It helps to troubleshoot networks and internet connections. The ping utility tests responsiveness between 2 hosts, computers, routers, switches. The tracer utility will also check responsiveness and trace the path of a packet that it takes to get from one host to the other. Some devices on a network will not respond to a ping because of what I just mentioned earlier. It could be a security setting on there, or the system's going down. It's having issues. System requirements. All OSs have tracer and ping built in, so I won't mention that again. Ping, though, is primarily used to find out if a computer is reachable. It accomplishes it by sending out special packets called Internet Control Message Protocol, ICMP, Echo Request Packet. These packets are special IP messages that are used to send information, network information between 2 hosts, like a computer, a router, a switch, and when a machine receives this request, it responds accordingly. Just like the scenario I told you about throwing you a tennis ball, you grab it and you throw it back accordingly. Okay, same thing that it does with the ping request on the server. There's a few examples. We already went over some. You can ping DNS names, the actual website name. You can also ping an IP address as well. All right. If you know the name of a computer on your network, you can ping that as well. All right. So when you ping it, it gives you immediately a response of the IP address of that domain name. Okay. It also gives you up to 4 replies in Windows. And what it does here in this example is an echo command is sent every second to apple.com When the ping program gets an echo reply back from Apple, it prints out the response, giving it several pieces of information. So it's doing this on that 4-packet response. It's going to the server and back, to the server and back, to the server and back, to the server and back. It's doing it 4 times. So it's not just like I'm throwing it once and then you guys are throwing me 4 times back. It's not doing it that way. It's I throw once, back, once, back, once, back, once, back. It does it 4 times. The IP address of where the echo reply is usually the IP address of in this case, Apple. The number of bytes that were set, the round trip time it took for that packet to go to and from the remote host, and the TTL. We're going to talk about now breaking down each one of these terms. The first one we're going to talk about is TTL. The TTL field, which is set relatively high usually, generally around 255. As the packets travel over the network, the TTL decreases by 1 for every node, server, or router it passes through. When the TTL drops to 0, the packet's discarded by the router. The main purpose of this is so the packet does not live forever on the network, and it will eventually die when it's deemed lost. If the TTL varies in succession pings, it could indicate that the successive reply packets are going different routes, like different switches are hitting. This could indicate that network routes may be experiencing problems, packets are being sent along different paths. And if you guys do a tracer every day on a server, you can see that sometimes. Say AT&T is working on a segment of their network, they might route everything somewhere else one day. And you'll notice a significant difference in change of network speed and traffic because it figures out where it wants to go and it goes a different route. The time field is an indication of the round trip time to get a packet to the host. The reply is measured in milliseconds. In general, it's best if round trip times are under 200 milliseconds. Okay? And you will generally have way under that. The time it takes a packet to reach its destination is called latency, which I mentioned in the first part of class. And if there's a large variance in round trip time, the network may be experiencing some problems, whether it be congestion, whether it be a switch is going bad. I've already went over how to use ping, but there is differences in OSs. So the Mac OS, give you the steps here to get to the ping utility. Linux or Novell, that's another one. You actually have to type in this command for Novell. And then Linux, same thing, ping and then the local host. Additional ping commands, if you're in a Novell environment or a Apple environment or Linux environment, Control-C to stop the infinite ping will stop it. If you wanted to print results of a ping to your local computer, we're not going to do it in here tonight because we're going to use a website to do the pinging. You would do ping, the website, greater than symbol, and then ping.txt. It would save in the root of your computer. Generally in Windows 7, it saves, I think, in the root of documents. Used to save in the root of C, but Windows 7 doesn't let you save stuff in the root of C from services like this, and so I think it puts it in the root of documents if you were to do it. You can tell it, though, an exact location. You can say C:\ping folder or something, and it will put it there if a ping folder exists. If you don't tell it where to go, it puts in the root of documents, I believe, in Windows 7 and 8. So, for example, if you wanted a Novell website, you would ping it here, and it would put it into the primary hard drive. You would leave out this extra greater than symbol, though you wouldn't need that. There's too many greater symbols. The next one is the T command. This specifies the computer. It pings until it's uninterrupted. So you can use this in Windows. It'll keep going on and on and on and on until you stop it with Control-C. So you do ping, the website, -T. Then you can give it a number as well. I can say ping, website, -N, 7. It'll go 7 times. Then I could do length, the length of packet. Remember the default's 32 bytes. You can send it all the way up to maximum of 8,192 bytes. And so here is how you would do that command. It would be a -L space and then the number that you want to send. Now here's the thing on trying this one. Sending larger packets may reveal network problems. So that's called penetration testing on your network. You can send packets of, say, 5,000 or higher and determine issues on your network. And what you're basically doing is mimicking congestion, mimicking folks downloading files of large sizes. And then lastly is tracer. We've talked a little bit about that. I do want to highlight a few things in here. The only thing it is not repeating in here is about what happens on those hops. Let's talk about that. So it works on a UDP port on tracer on your machine. The initial 3 packets sets the TTL to 1. Then it releases a packet. The packet then is transferred to the first router, completing the very first hop. Then the TTL gets decremented by 1 again to 0. Then the router discards that, sends it off to the next. So that's how it kills it and goes on to the next each time. Then the router discards that packet, sends it off to the notification packet, to the original host, with a message that the TTL is expired from the router. This tells Tracer what the first hop is and how long it took to get there. Tracer keeps repeating this, gradually incrementing the TTL until the path of the remote host is traced, or you'll find out tonight, it can also be blocked by a firewall on the server end when it gets there. So you'll see some hops show up all the way to the website domain, like for Yahoo or Google. And a lot of times you'll see those blocked now because they don't want folks to see the names of their routers for security purposes. So they'll be blocked out, and you'll see in a second when we do one. So response times may vary dramatically depending on long distances, network congestion. So let's see if there's anything else in there I want to mention. No, let's go to the next one. Let's go to the next document. This is the actual lab we're going to do now. I'm going to have you do this one, but I'm going to walk you through it real quick. So this document goes over the actual lab that you're going to be doing in here tonight. Let me get my window out here. Let's go to full screen. Okay. So this one is going to use that website I had you guys go to already, the ping.eu. And I already have in here a screenshot for the first one we're going to do together, and I'm going to let you do the rest on your own. But let's look at the first one. Go ahead and type in, you'll have to click on first the ping name on that website. It says ping. I think it's on the first line, is it not? As soon as you click on that, go ahead and it'll go to the ping site. It should have at the top your IP is something when you get there. And you should have what I have on the overhead. It should say ping. Shows how long it takes for packets to reach host. Everybody there? ping.eu. It's at the top of the document. We're in week 4 lab. There are the documents in week 4 lab. And you can just download the step 2 one, which is a lab. So when you type in google.com and click the go button, you should get a result, I'll pull mine up here, of that ping. So I'm going to type in google.com, click the go button, and notice it begins giving me a full response ping. Mine was, it looks like, averaging 31.2585 seconds on the round trip time. I got 4 packets were sent, 4 was received, 0 was lost. And total time was roughly 3,004 milliseconds. Okay, in total. And then it gives me the round trip time at the bottom. And so this is telling us to reach google.com from this server here. This is an external site. It's going to be a little longer probably than maybe if you did it from home, but it's a representative value and seeing what it does. And so what you're doing here is I went ahead and explained this, and I'm going to have you do the rest on your own here. If you look at number 2 underneath on your document, it says, notice the ping has 4 lines, 64 bytes each packet. It returns the IP address, the time to live, and then the time it took for the website to send it back. Now I'm going to have you do the same on Yahoo, Facebook, and then finally your favorite website, and you're going to give me on each one of these the average round trip time, the IP address, and I did not, if on 3, 4, and 5 I put in there IP address of Yahoo, but it's the IP address of whatever the website is I have up here. I just duplicated that. And so if you could do that on 3, 4, and 5, 5 is going to be your own website. And again, where it says IP address for Yahoo, that's IP address for the website you're pinging there on that number. Then finally on number 6, you're going to go ahead and type in that document as well what the purpose of ping is in your own words. Okay? So after you're through with that, we'll switch and go to the tracer. In fact, you can go right onto the tracer after you're done. You don't have to wait for me. When we're all finished, I'll kind of walk around. We'll talk about it, and then you're going to submit this document into the Dropbox when you're finished. And we're in week 4 lab. Number 2. It's all right.
Where's the text box on the site?
Where's what now?
The text box?
The text box. The text box that you type in google.com on the website. You have to click on ping first. You have to click on ping.
Oh.
There you go. And go ahead and write in that Word document or type in that Word document your answers, because you're going to submit this entire document to the Dropbox when you're finished, okay? Do what now?
For this, you want us to write how many milliseconds it took each time?
Well, you're actually not starting until number 3. You're doing Yahoo on your own first, and you're going to ping Yahoo, and I believe tell what IP address I believe for each one of them, or the average time, the IP address, and how many packets were successful.
I think the router is dropping ping packets.
Do what?
I think it's dropping the pings.
Well, we're using an external site. We're using a ping.eu website to do our lab. We're not using Rock Valley College's because of that very reason. Yeah. It's a pretty cool site too. We're not going to go over all of it, but I would recommend bookmarking this site when you get home because it's got a lot of cool tools and utilities on this site as well. Totally free. So after you guys get through with a ping, and remember on this ping one where it says on each one of the numbers IP address for Yahoo, you're typing the IP address for the site that's on that number, for would be Yahoo, Facebook, or your favorite website. I just did not put in the correct information on that, so apologize for that. Do what now?
You wanted us to take in, okay.
Yeah, you're just going to fill in that information, literally starting with number 3. You're filling in your own information there.
Okay, well, I'll just copy that into Word then.
No, you don't have to copy it into Word. It's already in Word. You just literally type in the answer
Oh, okay.
here. So what was the average round trip time for Yahoo? What was the IP address for Yahoo? How many packets were received? That's all you got to do. Yeah. Well, yeah. And when you're done, save it to your desktop. Save your document to your desktop and submit it into the week 4 lab if you're finished with all of them all the way down to Tracert. Because Tracert's the second one after you get through with the ping. There is a page 2 on this one. And this website's actually good too. Say you're having issues at work and you're wanting to figure out traffic outside, what it looks like coming in. You can use this website to ping yourself outside of your domain, and that's helpful too. I like to do that. It's really nice to be able to see that. And so it's a free service. They keep it updated. It's for educational purposes, and so cool service. It's got some cool apps on there too to download. How's it going over here?
Now, this is your IP.
That's your IP address, yes, here, that it sees Rock Valley's IP address as. And that's, you got 4 replies, which is good. And so all you're going to do, if you, on that document that I gave you, the Word document, you're going to type there number, or B is going to be the IP address. And you can highlight it and copy it. It's actually right there. That 206.19. Yep. Yep. Do what now? Oh yeah, I just mentioned that to him. Yeah, that's all right. Yeah, that's the old problem with copy and pasting. Yeah, and if you guys want to correct my incorrect spelling there on number 3, 4, and 5, where it says IP address 4, it's going to be IP address 4 Yahoo on 3, but it's going to be IP address 4 Facebook on 4, so on and so forth. That'd be great if you can do that. And if you need help, let me know. Yep. That would actually be 1 hop there on number 2. And it's got 3 locations or 3 different switches in that location. And I'm guessing the times are going to be it's going to be pretty close. Yeah. And a lot of times in that case, what they'll do is they'll have routers kind of daisy chained together in locations for just load balancing. And then when you see it, you see all of them. So I think it's a security reason too, because you don't know really which one it actually used. Hackers could maybe use that possibly. Yeah.
So would this mean it had 3 hops or would it be 4?
What's that? Yeah, go by the number. Yeah, when you guys get to the tracer, if you see 2 routers in a hop, it's still only 1 hop. The 2 devices only mean it's in that location. It's in that very location or that very building.
1, 2, 3?
Nope, go by the numbers on the left. See where it says 1, 2, 3 here? You have 1 hop, 2 hop, 3 hop, 4 hop.
So it would be 4.
5, 6, and 7 failed.
Okay, so it would be 4 then.
Yeah, 4.
Okay.
Yeah, you want to, I'm going over, I think I put in there successful hops, right? Yeah.
The second one?
So successful hops are different than actual, because most of yours will have, the last 3 or 4 will be failed.
It would only be 1 that was successful then?
No, 4. 4 was successful.
Oh, so
No
these
reply
3
was for 3 hops, and then, yeah, there's a question for that too at the end on why some of these do not reply with a hop. And you will find a lot of web servers now do block the hop when it gets there. They will, for the firewall, will block it from people being able to see the router name. And if you get done and other people are still working, you can keep playing with that website. There's a lot of cool stuff on there that definitely is worth looking into and using, bookmarking, jotting it down or whatever. And it's free, it doesn't cost anything.
That's something definitely customer persistence.
Yeah.
while ago, and it just it doesn't work.
Yeah, yeah, yeah. I started using it, I think, last semester here, so I really like it. It works really well. And they have some really cool services on the front end too. The who is that we talked about, DNS lookup, port check.
Do you know if they limit the number of who's requests you can do? Like if you're looking for the domain name, and you want to, you're just like punching in and see if they're registered yet or not?
The one you can do actually is if I think it's on the DNS one, you can type in the DNS lookup for any website. So say you're interested in a website, so I'll put in mine. I know it's my website, so I'll type it in. Up says there's a server address. I have no authoritative name. It's through GoDaddy. And then if I was to highlight this IP address here, and now go back to the who lookup, the who is lookup, should get some more information. There it is. There's my GoDaddy website, the IP address, and it gives all information. Of that. So yeah, you can do who is what I'd recommend. Who is going to give you more detail than anything. And if one's not available, it'll just say it doesn't have it. This website's available. Because I have my contact information hidden where people can't see it, but you can make that visible. So if I put in another one like yeah, you can actually tell them it to be invisible or to be, the domain that you're hosting it from has to be visible, but the information that can be hidden. Yeah. The main, like this one here, EduCause owns Rock Valley College's information. I'm guessing for FERPA reasons. They don't see that information now. Oh, that's interesting. Facebook.com is registrar through 2cows domains. Whoa, they got a lot of domains. Ooh, Ukraine. Do it.
On the second one for Trace Road,
Yeah.
the second top, it says 3 of them on the same one, on 2.
Yep. That same location. Same location. Have a daisy chained routers that we'll talk about. Yep.
Does that count as one hop?
It counts as one hop. Yep. It does count as one hop. Yes. You want to use the numbers on the left side. That's your actual hop. On the left, the literal numbers they give you there.
But you also want to add to that the ones that were locked and
if it's, the question I think I have on successful hops, only give the ones that are successful. Then I think, ask at the end, what about those that aren't successful? What's the reason for that, you think? And it gives an explanation at the bottom, kind of what the normal reason is. Just jot that down, so. But,
I might have accidentally deleted something from it.
do I know?
Might have accidentally deleted something from it.
Oh,
So at the bottom here, it says, I'm looking at the trace route, and it says no reply for 3 hops.
yep. And why does it say it's no replies? It says right below there. Why does it say there's no replies?
Right at the bottom, it says other function, assuming firewall.
Yep, right there.
Assuming firewall.
But what does it say before that? Assuming you use firewall.
No reply for 3 hops.
No reply for 3 hops is for, the reason is what now?
Assuming firewall.
Exactly. That means that they're probably using firewall to block users from trace routing those routers from being seen.
Firewall on the router.
Yep. hmm Yep, definitely.
So what's the answer?
Right there, you just told
How
me.
many successful hops?
How many successful hops? That means how many actually successful. If you look on the overhead on mine,
Oh, 4.
you go by the number on the left. Okay, so I've got 8 on this one that's successful. 8 of them were successful here. Notice this one has 3 of them, but it's still only considered 1 hop because it's the 8th location. And then the bottom 3 were unsuccessful
Oh, okay.
because of firewall.
So successful would be 1 for this one.
Where it says, what do you notice about the first column names, what does that mean?
That's up to you to tell me. What do you notice about the names of the routers? Anything jump out to you about the names? Do they make any sense to you? So just give me your thoughts on it. We're going to talk about it at the end. We've already talked about it a little bit, by the way, what the names mean. So that's interesting.
NASA.gov doesn't produce any results.
Do what now?
NASA.gov does not produce any results.
Security.
Blocking
It
everything.
doesn't, it won't even bring up anything. Whitehouse.gov does, but
Yeah, it's probably for security reasons. Okay, anybody still working on your lab? How many still working on it? Okay. When you do get finished with your lab, save it to your desktop, and you're going to submit it into that Dropbox in week 4. I'll give you the instructions are already in the Dropbox. You just gonna attach this and submit it. And then we will go over your results and discuss some of the other things that you might have found as you were going across the lab.
mean was like ditto on a line.
That means it was not reached. There was no reply.
That'll be one that failed, right?
Yep. And that's generally for firewall purposes. They will fail. And we'll look at some examples in a second.
Now, it says no reply for 3 hops. Those are, okay, no, those are the ones with the firewalls, not, so they didn't necessarily fail.
No, they failed.
They did fail. Well, it shows no reply for.
No
3.
reply means, no reply means that no reply. And it's generally a firewall block.
But I'm seeing, looks like I see 4 that actually did, looks like 4 failed, but it shows no reply for 3.
I don't know what you mean by that.
So like line 13, there's nothing there, but you get the
Yeah, that's a
reply.
fail.
That's
Uh-huh.
a fail.
That's a no reply. That means no reply. They're all no replies. When you see it asterisk, 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 that's a no reply.
No replies or fail. So no reply for 3 hops is saying. That, I mean, it says that is that the same, there's no reply?
It's really 4. It probably just caught the last 3. It looks like 4 though for that one. You got line 13, line 16, line 17, line 18 failed
Now, the
with no
fact
reply.
that there's so many hops here,
Mm-hmm.
it's just going through more routers. Is that what that means? Like Google, I think it was only 4.
Mm-hmm. Yeah, it's taking that many. It's taking that many routers to make it to the destination. It's hitting that many routers.
So it's going to the UK.
Yeah, and then if you actually, we'll do in a second. You can actually highlight this IP address, and then later do like I'm doing. You can do a who is on the IP address. It'll give you exact information about those locations. But a lot of them, yeah, you can actually make sense of it by just the name. UK, yeah, here's was like France maybe, and then UK, and then US, and then
Phoenix, maybe?
yeah, maybe Phoenix. Yep. What that one there? Management Phoenix, and then Phoenix. Well, there. What website's that? Adam Beauty. Are they located in Phoenix?
It's mine.
Oh, okay. The server located, the host, I'm guessing.
Well, it's in GoDaddy.
GoDaddy. Okay. Their servers are located everywhere.
The biggest problem is primarily Phoenix.
Is it Phoenix? Okay.
Most of them are.
Okay, I didn't know that. Cool. All right, how many still working? Almost done there? And if you are finished, you can do what I've been doing. You can actually, if you're interested in, like, say, the last couple hops, the IP address location, where they are located, you can do a who is on those by highlighting the IP address column and doing a who is and figuring out what their who is information is, company information.
Can we have 3 columns that shows how long something is happening, or how long it takes for a reply, I guess? So like
Yeah.
here,
Mm-hmm.
there's one, and there's one.
Yep.
So what does that mean?
It does 3 in that location, and it gives an average. And so the first 2 are going to be the actual ping times, and then the last one's going to give you the average of that.
So the question is, which hop took the longest?
Oh, that means line by line. So I would go by, actually it's going to be better for you to go by, it doesn't matter, like say you can go by this first one, this first column, it's fine. And so, yeah, it's pretty no-brainer on that one. You go, what line, yeah, that one's going to be the longest. Yeah, I don't want you don't have to give me a number, just say which hop took the longest. Give me the number 4, number 5, number 6, whatever. That's fine. Do what now?
So now I want you to trace around 4 websites to be your choice.
Uh-huh.
The Yahoo for website 1 will not be. Is that supposed to be in that website?
Yeah, whatever website you want to do, of your choice.
Oh, okay. Well, for website 1, I did Yahoo.
Yeah, that's fine.
Just go to Yahoo.
Yeah. Yeah. I can-
B doesn't mean anything.
Well, I think that was supposed to be just one spot. So Yahoo's for that one. Website 1, you can do Yahoo there. You're just going to basically put your website in the line where it says website 1.
Okay.
And it's going to do 4 of them. Okay, after you're complete, make sure and submit this to the Dropbox. While you're still working on it, some of you, I'm going to go ahead and continue on here and talk about the tracer real quick before we get into the ping. Ping's fairly simple, but tracer, I want to mention something real quick. Let me go to my screen and my tracer command. It was always in a document. Each tracer, each time you went to a router, had 3 numbers, right? And I wanted to mention that those 3 numbers, I'll bring up what we went over earlier. Every hop is going to be given 3 packets, 3 initial packets for the time to live. So that's why you see the 3 pings, or it's because it's given 3 of those areas. Now, you'll notice on some of those routers, it didn't use all 3. It might have used 1. It might have used 2. Okay? It's given 3, though, for each one. And so you have up to 3 columns for that location, or 3 routers to be hit in that location before it goes on. It dies and goes to the next hop. Okay? So the 3 hops, if we go to the example on the website for mine here. Okay, notice my first hop on this example here took 2.163 milliseconds. The second hop in the same location, different router, 2.359 seconds for the hop. Then the third router was 2.379. Then it dies, go to the next location, 0.144 for the first hop, second hop 4.6. Third hop didn't need it. It died. Maybe didn't have a third location there. Fourth one just had 1 location. Didn't have 2 other. And there will be some locations that only have 1 router in that location. And if it has 1 router, or it only allows 1 router, it only has 1 hop. Then it kills it and goes on to the next. That makes sense? And you'll notice also on these, from the first to the third doesn't necessarily mean it's going to be from in any order of speed. This one here, you'll notice, took 11 milliseconds on the first hop. Second, almost 4.791. Third, 4.789. Okay? So it gives 3 per location, 3 hops per location internally, or 3 time to lives is what it's called, not 3 hops, 3 TTLs, because it decrements it each time. It starts out with 3, then 2, then 1, then it dies, 3, 2, 1's not there, it dies, 3, tries 2 and 1, it dies, so on and so forth all the way down. Okay? So I wanted to mention that. Also, one of the things I thought was kind of interesting, if you had time to do this, the naming, one of the questions on your lab was, did you notice anything different, or did you notice anything different about the names of the column in the tracer, the first column? And as I was walking around, some of you said, "Oh, that looks like that's the country U.S., or that's the country France, or that's the country, oh, that's UK, oh, that's Arizona." So that's what I was looking for, was location-based. It's location-based. Some of them you can actually see the name of the location, some of them you can't. If you can't see the location, like this one right here, I have no clue, right? What I can do is highlight the IP address and then go to the who is, like we talked about, I'm going to paste that IP address in the whois. Click go. It's going to give me contact information here for that last IP address. And notice it's Microsoft global.net, and actually address on this one is Redmond, Washington. Okay, for that one. And you can do that on any of these that you have no clue where it's coming from maybe, is you can highlight the IP address, copy it, and do a whois to figure out where that information or where that router's coming from. This one's Frankfurt. Frankfurt, Germany, and here's the actual address in Germany. And notice this one reveals some phone numbers and fax information as well. Okay, and so it's good information to have. So let's go ahead and quickly, I'm going to go over your lab while you're finishing up there. So on the ping, you guys did a Yahoo ping, a Facebook ping. Out of those two, which one took the longest in maybe average round trip time? Between Yahoo and Facebook, which one took the longest? Which one took the longest average round trip time? Facebook or Yahoo? Yahoo. By how long? What was the differences?
179 to 103.
Okay.
76.
Now, in all the pings you guys did, was there any packets dropped, or was it 4 on everything? Did you get 4 received, 4 sent, 4 received on everything? Okay. On your favorite website, any high amount of ping you think on that, or high amount of average round trip time, or was it pretty average? What was yours?
8,006 milliseconds.
So
And it dropped.
almost 8 seconds, and it dropped some packets.
It dropped all of them.
It dropped all of them. Okay. Do you mind telling us what your website?
Pinterest.
What is it?
Pinterest.
Pinterest. Okay. And more than likely, it's blocking that from being pinged, blocking it from pinging at all. Okay, good. So what's the purpose of ping? Somebody tell me what what you put down for the purpose of ping, in your own words.
Diagnostic purposes, if the destination is reachable with reasonable latency.
That's a good definition from the book, or from me, or but no, seriously, what is your like? If somebody that knew nothing about networking asked you, and couldn't understand anything about it really, technical stuff, in layman's terms, or what is an easy way, or maybe if you could use like an analogy maybe too, what would be one you would use maybe to define ping?
To see if you could get something from here to there.
Yeah, that's good. That's excellent. That's a good definition. Anybody have anything else you want to share on ping? What you put? Anybody?
I wrote a check speed and connection of any website, and it'll help solve transmission problems.
There you go. So help solve transmission problem. That's good. Excellent. Okay, now on the tracer, notice some of you are having a lot of fun with that one. You were looking up the whois and figuring out where things were coming from and things were going. Out of all of your sites, starting with number 6, on number 6, where you had to tracer your own websites, out of all of them, which one out of all the websites had the most hops out of all the websites you looked at?
China.cn.
What was it?
China.cn.
China.cn. How many hops?
19.
19 hops. What was the least amount of hops? Somebody else? Least amount of hops on the 4 that you chose? 9? And what was the website for that?
Rockcollege.edu.
rockcollege.edu, okay. Let's see, on this one, okay, out of, pick any one of them here, maybe the highest one. Let's pick the highest one, the highest amount of hops in your individual search. What was the longest time in any individual hop for, let's say, the website that had the most hops, like China or whatever. So what was the longest one for you guys? What was the longest for yours?
I didn't write down the milliseconds for it, but
That's fine.
I think it was about 370.
370.
And that was
That's
the
pretty.
transatlantic hop, so.
There you go. Okay. Anybody anything higher than 370? Did you say 370? Anybody even higher than 370 on your return? No? Okay. Guess what? You're done. What do you guys think of that utility, by the way? It's pretty cool. I'm going to go to while you're uploading your stuff to week 4. I wanted to show you some stuff on this site, and I definitely think you should use it at home or at work to maybe ping your own network and web server. But I want to talk about a couple of these things here as we're wrapping up. The DNS lookup. When you click on the DNS lookup, it'll look up the record for that website. So I can type in IP address or host name. So if I type in, like say for instance, I type in msn.com and click go, it'll tell me the server name, the address of the server name, MSN, and address. Okay. I can highlight then the address, the IP address. And then I can go back and maybe I want to do a who is, and remember who is lists the contact information for that website. And there it is.